So after you have imported the data, we can see here that in our environment, we have this data frame called data. We click it, and this is it. But if you have a larger data set, then it's probably nice to see the first instances. You can do that with the data.head method, which will give you the output here. So here you see the 5 first instances of the data. What you can do is that you can increase it to, for example, 10. Then you will see the 10 first rows of your data. If you have a different IDE than this interactive window here, then you probably need to print the output. Then you get this. If you do not print the output in the interactive window, you get the a bit more nice formatting here than the print function actually outputs. If you want to check the last rows, then you can use the tail function. Like this. So here we see our last rows, and we can see that there is one not a number. The NaNs can also be found by describing the data. We use the describe method, and here you have the description of the data frame. So you get the summary statistics, like the count, and here you can see that the count is it's in engineering notation. So this is 2 times 10 to the power of 1, so it's 20. So you see that there are 20 instances here and 21 in the other, and 21 values in the other columns, which means that you have one column with a missing number for price. And of course you get the mean, standard deviation, minimum, the percentiles here, and the maximum. Right here you have a lot of decimals. So what you can do is that you can round this data. Then you use the round function. You put whatever you want to get rounded in here, and you decide how many decimals you want to cut off. So here you see that the result is much more pleasant to read than this. So here you have the count, 20, 21, and so on. And then you have the mean, and so on. Just beware that we do not have the last column here. That was the city column. It's because the city column is text. And if we want to include the city column, then we can just write data, describe, and then we can include all. So if we hit this, shift enter that, so then we see that now we have city, and we have some other summary statistics. We have the number of unique values, which are not proper to use for the numeric values or variables. We have the most common value and the number or the frequency of the number one or the most common instance. So for city, there are two unique values. We know that from looking at the data frame. We have Oslo and Trondheim, and the most likely value is Oslo with 11 instances. So that's how you get the summary statistics also for string variables. If you have a large data set, then you would like to get the unique values of any string variables to see which values you might encounter. Then you could use the data for, in our case, city, and the unique method. If we print this, we get Oslo and Trondheim. Data type is object in Python. This means that it's a string variable. You can also get the data counts. So you get data, city, and value counts. So here you also get city, Oslo, is in 11 instances, and Trondheim is in 10. You can also use the info method to get which kind of data type every single variable is imported as. Here we have a decimal number, that's price, and all other numerical variables are integers, that is whole numbers in our case. And we have one string variable. So here we can also use the drop NA method to drop any rows with missing data. Because here, by using the info method, we can also see that we have one missing for price. All others have data for 21 rows, but price only has 20 values, which means that there is one missing data. So then we can put in data the data.dropNA. So here we use the dropNA method. So what we get from this is a cleaned version of data, and we put that in data. So if we run this, and then we go down here to our variable explorer, and we click on this, we see that now we only have 20 rows starting at 0, ending at 19. And row index 20 is missing because it lacked the price. What we also can do to investigate the data frame is that we can plot these against each other. Then we use the PD, which is the pandas, which we imported, plotting, and here we can use the scatter matrix method. And the scatter matrix takes in data, and if we run this, it will take some time, and you will get quite a bit of information here. But here we have the scatter of all variables against all variables. And if you have price versus price, then you get the histogram instead. And you can expand the window by using this button here. But this does not look very nice. So what we can do is that we can increase the figure size. Figure size equals, for example, 2015. That's quite large. And if we run it again, then it looks a lot better. Not perfect, but it's okay for our purpose. And now we can check this figure and see that, well, here we have two values for Oslo, 0 and 1. Okay, and parking, 0 and 1, and so on. Balcony and terrace. So most of the instances or the observations in our dataset, they have a terrace or balcony, and some few of them do not. Whereas bathrooms are either 1 or 2. Some few apartments do have two bathrooms. So this is how you can use the plots function from the pandas library. You can also calculate the descriptive statistics manually, like such. If you would like to look at the price variable, then you can get the minimum value of 1.58 million. You can get the maximum value. Let's see here. We just do that, and you use the max function here, 6.99 million. And you can get the mean, which is the average of 3.9 million kroners. You can get the variance, which is a measure of the variation in the variable, and the square root of the variance should be the STD, which is the standard deviation, which is also a measure of the spread or variation. And what you also can do, you can calculate the skewness of the distribution, and you can calculate the kurtosis of the distribution as such. So this is how you can explore the data and clean the data and get the individual values for these summary statistics.